Okay, welcome back to the graphics guy. Today we're going to look at the 2018 higher level junior cycle junior certs section A. So starting off there again, 15 questions, you have to answer 10, but you're better off to answer at least 12. Do a couple of spare ones in case you make mistakes. So again, the first one there, we'll just have a look. So one here is the hexagon, 6 sides. And 2 is the parallelogram. And 3 is the octagon. So 4 must be the trapezoid. And again, I would always do the ones you're certain of first and then see what's left. Okay, now question 2. Very careful now. Look at the pictorial here and see what clues or what hints are being given. So we know that the back corner is directly below this point here. Okay, so I'm going to find that first. So this top corner here, it's like our creating idea. If that pommel horse gymnastics thing was in a crate, so I am going to vanish this forward. And that there is this point up in the air. So when I come down, now that there is a key point because that is this point here on the ground. Okay, so I now can vanish and heavy in that. Just get a heavier pencil for this now. So there is the top vertical part. Here is our slope coming down to the ground, and then that gives us these section lines here for the different colors and that. And I'll just heavy in there now and be sure and heavy in all the different lines here. Okay, so that there is section 1 and 2 and 3 done, and 4 is the vertical surface here. So now what I need to do next there now is just the top. So that's parallel to all of these, so that's going back towards there, and this gives me that back corner there now that I was looking for. So I'll just heavy that in. So it just had to complete the perspective, so there's no marks to be got for colouring in or anything like that, so I'm going to just leave that now. But again, just always be watching out for these little clues off the pictorial really. Now question 3, some trigonometry. So again, I would be inclined to start here. If that's 80 and 50 is 130, I'll just write down the maths here. 80 and 50 is 130, so the whole thing must be 180 minus 130 is equal to 50 for A. So A is 50 degrees. 50, just write it in there. So 50 and 60 is 110. So A and 60 is 110, which means that this here must be 70, because 180 minus 110 is 70. So angle B is 70. And then what is angle C? Now, if I was to extend this here, I'll just look at one or two ideas here now. If I was to extend that and bring that up here, so whatever angle B, and we know angle B is 70, so if angle B is 70, this angle is 70, that angle is 70, and the remaining, so even off this much would do. So if this straight line angle here is 180, so it's 180 minus 70 is 110, so C must be 110. Now I could have also got that from down here, because if 60 and 50 down here is 110, well, that 110 there is the same angle as angle C up here as well. Now guys, question 4. Again, I think it's a good idea to count boxes here. 1, 2, 3, 4, 5, 6, 7 up here, and 2 more there. So the full width is 9. 1, 2, 3, 4, 5 between here. Just get a couple of the main measurements sorted out, and 1, 2, 3, 4, 5 up to here. Okay, now our starting point here, then we have one leg here, so that's started off for us. So I'd be inclined to go here with the space of 5, 1, 2, 3, 4, 5. So there's the other leg, and then vertically it goes 1, 2, 3, 4, 5, 6 up to the tabletop. Now I would be inclined to draw this light, because as we progress, sometimes stuff is hidden when it's drawn in 3D. But anyway, I'm going to bring these up there to the full height. So again, 1, 2, 3, 4, 5, and 6. So these come up 1, 2, 3, 4, 5. Okay. Just lighten that off here now. Now, width-wise there, that's 1, 2, 3, 4. Going back this way, 1, 2, 3, 4. So we've got all that. Okay, so this gives us here now the edge of the table, except the problem is that there's a tray sticking out here too. So I need to project this out 2 more here now. And then that goes back 4. And then down 1. Okay, now this is probably the worst part of it over here now, because I can now start to heavy in stuff a little bit, because I now have this definite edge, and I'm going to put a color on this here now just to kind of highlight where we are. Okay, so that there now is that yellow surface edge out here. Okay, so I'm going to do some heavying in now. So we know now that that's going heavy all the way over for 9. So I'll just double check 2, 4, 6, 8, 9. Okay, and that's our leg here. Okay, so that's that front surface here taken care of. Now, the slope there on the top of the barbecue hood here goes up to and back to, so basically it would be up to and back to. So that is here, and it's the same then from the top of this, so it goes up to, back to. And now that should be 7 boxes here, 2, 4, 6, 7, so that's correct. Now it goes back 2 more here on top. Drops back down 2 here. Okay, and that's our tray here. So I can just have you know where the leg disappears here. Now, to finish taking out that cut in the leg here then, and that leg is 1 box thick. Okay, now, so I move on into the back leg there. So again, that goes in 4, 1, 2, 3, 4, and up. And then the inside part of it is 2, going up to disappear. A thickness then of 1. And I think I'm okay now to put some colors on this. So, because don't throw away the easy marks for colouring there, so just put the barbecue hood here in this cyan colour. Okay, that'll do. So on there then to question 5. So this there, it gives a triangle ABC, convert the triangle into a rectangle of equal area. Now again, conversion of areas really is about knowing a couple of simple rules that basically half the perpendicular height is what we're looking for here. So that's our perpendicular height. So we need to get half of that height. So I'm just going to bisect it with a compass. So open your compass more than halfways. An arc, and then from the top another arc. And half the perpendicular height is this, and that there then basically is the answer. So I'm just going to put this in color to help you see it. Okay, so that there is a rectangle that is equal to the triangle. Now just to take 1 second there to show you a little something to help you understand this. What you're really doing here is, it's like taking this yellow triangle here and moving it down to there. And taking this cyan magenta color here, that triangle, and moving it down here. So basically, the main thing to know for areas is, if you want there's a triangle, half the vertical height is a rectangle, and it works backwards. Then other times there, if you were given a rectangle and told to make a triangle, if you double the height anywhere, that triangle is equal to the rectangle in area. So that's area conversions. Question 6. So we've got a gavel there, which is like an auctioneer's hammer, and the block or a judge's, and so you want to rotate it there until ABCD hits the top surface. So just rotate, set my compass here. So this is the key point here. This is where D is going to hit the block. Now what I'm going to do there then is I'm going to just get this distance DC. And I will just draw this in here. Now I'm going to put this in red so it stands out. Okay, so that's DC in the new position. Now what you could do here now, if you wanted, is I'm going to find, I'll call it X. I'm going to find X, which is where the handle connects on here. So that's in the middle there. Just take that distance from D. Okay, so there's our handle. Now we can use this now, because I could solve this, the rest of this now, 2 ways. I could use rotations, or I could use the fact that the sides are parallel. So I'm going to just look at that option for a second. So since the sides are parallel, what I could do is just go parallel here, parallel there, and again I could use measurements from here now if I wanted, but I'm going to use rotation because the question is a rotations question. So B and A have to rotate down in that direction, so that's going to give me B and A. And there we go. Now next up here, question 7, which is an auxiliary elevation. So here's the XY line. So what we're doing here is we're going, instead of looking straight in to see this object giving us this front view, we are going to look up here to see the true shape of surface S. Now look, I will put a color on this just to help people to follow this. So look, if surface S was green In relation to auxiliaries, I do think colour helps you to understand it a lot easier. So if surface S was green, that's surface S in the front view. But this is the key thing here now. Here is surface S in the top view. And we want to see the true shape of surface S, so we need to look perpendicular to that. So this is already kind of set up, so they have the XY line put on parallel. So I'm going to do this slowly there now, just so people can understand. I'm going to bring up surface S on its own for starters. Okay, now the high part of surface S is on the left. And the low part is on the right. So that there is all of surface S, and I'll just heavy that in. And I will colour that in. Now, the problem is that you need to draw the rest of the object as well. Okay, so that is the easy bit done, but I need to draw in the rest of the figure. So when I project up here, I'm going to work my way around here now. So the left hand side of the object is the high part here. So that there is that other point over here, that high point, and then it slopes down to this point here. So I'll just put them in dotted. And that's sloping up to there, so that's all the high sloping part of it done. And our next problem there now is the rectangular box that's sticking out here. So this is a lectern there for giving lectures off of. So that rectangular box is sticking out here. So there's the top of it, and I've got to take a height for the bottom. So that there is the height for the bottom. And all that remains there now is that goes the full ways across. So all I've got to do here now is just find this far corner over here, that vertical surface going down there, which is here. That's the bottom of that going all the ways across. Okay, so that's this edge here, and that is that edge there, and I think we're done. So question 8. Freehand pictorial sketch. Now again, proportion is the key here now. So like this is the width and the depth, and our heights coming from the front view. So I would be inclined there now to draw this rectangle. So I'll be setting up my crow's foot. So that's about the length. That's about the width. And now I want the height of the stamp. I'm going to do the back part of this light because it's going to get blocked out by the middle section afterwards. Okay, so the next thing I want to find here is the center of this roughly. Now, you could cross diagonals, but I'm just going to estimate that the center of it is about here. Okay, so that's going to be the center. And what I'm looking for here now, I could box this in if I wanted. Now that circle there, the middle part there of the handle of that comes to about 2 mil back from the edge. So I could put a square around this if I wanted and draw in roughly a semicircle there like that. Now, the left hand side of that then is going to go up for about this height. Now again, proportion is the thing. I want to get the proportion fairly right. So roughly the same curve as the bottom there then. And now it slopes out a bit wider here then, just a little gradual slope. And on top here then we would have an ellipse. Now it says color or shade that, so I'm just going to heavy this in a bit first. Now I always think coloring is easier than shading because you don't really have to think too much about it. So what I'm going to just do here now is I'm going to put a surface underneath this. Now, you don't want to spend too much time in an exam, but I do think it's probably worth the extra minute that it just takes there. It makes it look so much better to put a surface underneath it. Okay, so that's coloured, that'll do. Now some of these questions do take longer than others obviously because like I said, there's a bit of drawing in this, there's a bit of work on that, whereas some of the quicker questions are in the CAD commands. So the first one there would be an ellipse, that would be dimension, this would be an offset, and that would be an extrude. So, or push-pull, depends on what package you're using, but in SolidWorks it would be an extrude. Now, question 10, Angry Birds said to draw the plan of the sphere and locate the point of contact between the sphere and the block. Okay, so step one anyway is just to project down center. So the size of a sphere, it doesn't change. So once I set my compass here, if that is the radius of the sphere in the front view, that's the radius, same radius in the top view. Okay, so there's our sphere, and just to use some color here now. Because the sphere goes over the container, that's going to be dotted there. Now our next problem there then is the point of contact. Now the point of contact is going to be a 90-degree angle to the surface that it's touching here. So that sloping surface here, if that's the angle of that, we want to go at 90 degrees off that through the center. So in other words, this angle here is 90 degrees there, that angle there. So that there is the point of contact in the front view. And then when I project that down, because it's in the middle, it's going to be here in the top view, and it just said the point of contact between the sphere and the block, so that's all we need there, so that's that sorted. Now question 11. ABC is based on semi-ellipse, and you have got there the focal points and a point in the curve. Now you need to be careful here a little bit, because you've got the focal points which would be in here and in there. So that's what you've got. And what you need to know here now is a rule of ellipses, that from the focal point, and I'll draw this in, and point P is here, from the focal point to any point on the curve to the other focal point, that distance is equal to the major axis AC. So how do you actually do this now? So we know now that if I add that distance and this distance, it's equal to the major axis. Now you could do it mathematically, which would not be my chosen way, but I could say, right, that's 35. And this is 75. So I'm getting 110 for the major axis. So I'd be setting my compass there then to 55. But seeing as the subject is graphics, I'm not going to do it that way. I'm going to do it using the instruments, but there's two ways to do that then. I'd have a slight preference for if I just take a zero distance down here, just mark that anywhere, and if I take FP and then add PF1 to it, or PF2 to it, that there now is the length of my major axis. Now if I check that, that should be 110 as well, which it is. And a third way to do that is I'll just extend this line up here, and if I swing P to F up here, that's like adding that on in a straight line. It's kind of the same as what I did down here. That's another way of finding it. Now that we've got the length of the major axis, your next problem is you need to bisect it. So I'm going to do that with a compass. So again, I'd have a slight preference for doing the one that's not on the drawing, because it just keeps the question a bit tidier. So I'm going to bisect this with a compass. So here is the middle. So that's going to give me the radius for the major circle. Okay, so that's our major axis, or major circle. And from the pictorial here, we can see there then that the boxes, I'll just put these in colour just to highlight it there, that the boxes come out level with the major circle, and the same with the other side. So I'll just finish them off. Okay, so that's our major axis found. So we know then that half the major swung from the focal point gives us the minor. Okay, so you can see it doesn't matter which focal point. So I'll just draw the minor circle. And put on a few spokes, 30 and 60. So where it hits the major circle down, where the spoke cuts through the minor circle across. So there's some points for half of our ellipse here. And I'll just transfer this one across because we have a point up there. You could do two if you wanted. So I'll just use the fact that it's symmetrical, so however far it is to the left, same distance to the right. And there we go. Okay, so there's the length of the major, minor, and draw the logo. Then here, okay, so just having a look at it to match the correct letter there. So C is the one where, again, I would do the obvious one. So C is the one where everything is heavy. So that has to be C. And in this one, in a top view, they're all dotted because they're all underneath the big one. So that has to be A. So this must be B then, where one is hidden and the other two are heavy. So BCA. Now question 13, it says here, it's a car mirror and show clearly all the points of contact. So you've got the centers of all the arcs. So what you would need to know here is that the point of contact is always on the line joining the centers. So that's 1. And this here is 2. I'll just number them there. 1 and 2. Now, this one, that big arc there, tricky enough now, alright, easy enough to miss that 3, and then 4, because this is the center for the big arc. Okay, now, because that's a tangent to the line, that's 5, and this one is also a tangent there just to the line, 6. So 1, 2, 3, 4, 5, 6. So that's all the points of contact. Now question 14 here then, a well proportioned freehand sketch of the elevation of the camera viewed in that direction there. Okay, so again, proportion is the main thing here. So if I start off here with, as I said, that's going to be the width of the camera, and the height of it is about, I would say, half the width. So that there is roughly, and I think in the center panel here is roughly, I would say that's kind of square. So that's our center section here, and we've got a slope coming down here a little bit. Okay, now a small bit then, I'm going to leave the circles here to last. So a small bit to the left of that is this top part here, and there's a slope there of, I think it's around 45 or 50 degrees. And next thing I'm going to put in the button here, which would be roughly about there. So there's our button. Now, the last thing remaining here then is the circles here from the center of this. So now you could, if you wanted, put in a square for this. It depends on how good you are at drawing freehand circles. So like if I wanted to put in a square here for this, and then just an offset of that, and this didn't look for any coloring or anything, so, or shading or anything, so there's our front view of the camera. Now finally there then, question 15 is presenting data graphically. So sometimes it's graphs or charts or whatever there, but this time it's a pie chart. So the nationalities of the tourists, there was 12 and 6, 18, 21, 24. Now there's different ways you could do that depending on how you are at maths, I suppose, really. But considering that there's 24, I'm going to do it using kind of fractions really, I think. So 12 out of 24 is half, is the UK. Now we're asked to colour this, so I will just stick some colours on this. Okay, so that's half. And if you wanted to there now, we could put in that that's 12. So you're left with 6 and 3 and 3, which is 12 as well. Now you'll notice there are 3 and 3 and 6. So again, if you're good at maths at all, or even you don't need to be great at maths, but like 6 is going to be a quarter. That's going to be a quarter, which is the United States. I'll say US. And that means that what we're left with here then is 6, which is 3 and 3. So just use a 45 degree set square here to break that up. So that's 3 and 3 for France and Germany. Okay, now I suppose you could do this mathematically, because you could say like, I'll just take, let's say the United States, which is 6 there. So if you were to do that mathematically, it would be 6/24 of 360 degrees. And if you do that, that would be 1/4 of 360, which would be 90 degrees. So you can see the US there now is a 90 degree angle in the center. So you could do it that way as well. But when the numbers worked out like that there, I think just using fractions works out handy for this. So that there is the 2018 higher level section A.